Hello, this is Ms. DB, and today we are going to begin talking about Chapter 5, Section 3 on solving quadratic equations by graphing and factoring. Our objectives for this lesson are to solve quadratic equations by graphing or factoring, and also in the second video we'll learn how to determine a quadratic function from its roots. Alright, when would we need to use something like this? A lot of times when we talk about quadratic functions, we're talking about the path that a projectile makes, like a ball that is kicked is one example. It says in this example, when a soccer ball is kicked into the air, how long will it take for it to hit the ground? The height h in feet of the ball after t seconds can be modeled by the quadratic equation h of t equals negative 16t squared plus 32t. Remember, t is time in seconds. In this situation, the value of the function represents the height of the soccer ball at different times. When the ball hits the ground, it'll be 0, because height will be 0. A 0 of a function is a value of the input x that makes the output f of x equal to 0. So it's what x will be such that the answer, when you put that x in, will be 0. The zeros of a function are the x-intercepts. That's very important. The zeros of the function are the x-intercepts. Because it crosses the x-axis, that's when y, or f of x, is equal to 0, right there on the x-axis. So right here, this quadratic function has two zeros because it crosses through the x-axis twice, and that's when y, or f of x, would be equal to 0. Linear functions can only have one zero, but quadratic functions can have two zeros. They can also have one zero or no zeros, depending on the quadratic function. They're always symmetric about the axis of symmetry. So if you know the axis of symmetry and you know 1, 0, let's say it's 2 units away from the axis of symmetry, then the other 0 will also be 2 units away on the other side of the axis of symmetry. So they're always the same distance away from the axis of symmetry. Any pair of points with the same y value are symmetric about the axis of symmetry. That's just a hint. All right, so let's look at what we're going to be doing for this assignment. The first question says, find the zeros of f of x equals x squared minus 6x plus 8 by using a graph and a table. Now, I highly recommend that you graph these using Geometer's Sketchpad or your TI-84 or 85X, whatever you have, or you can use Desmos.com is a very nice graphing calculator. There's probably others out there as well, but those are my recommendations. If you graph them on an online graphing calculator, then you'll be attaching your screenshot. If you're graphing them on your graphing calculator, then you'll have to sketch graph in the worksheet or by hand and then scan it in. If you graph at Sketchpad, you can just attach your graphs. All right, so we are going to graph this function, x squared minus 6x plus 8. We know some things about it already. We know it's going to open upward because the number in front of the x squared term, the a, is positive. We know that the y-intercept is going to be 8 because that's what c is. This is written in standard form here. We can find the vertex. To find the vertex, remember we use this little tiny equation of x equals negative b over 2a. A in this is 1, b is negative 6, and c is 8. So we would just take negative 6, which is 6, over 2 times a, which is 2, and we get 3 for the x-coordinate of the vertex. So we know that that's what the x-coordinate is. To find the y-coordinate, we would plug in 3, and we'd get 9 minus 6 times 3. 9 minus 6 times 3 is 18 plus 8, and we would solve that and get negative 1 for the y-coordinate. That's what they're doing right here. So now we know where the vertex is. We know where the y-intercept is. We know the axis of symmetry would be x equals 3 because it's equal to the x-coordinate of the vertex. And we would graph our function. Now the question asks us to find the zeros, so we want to make sure that when we plug in our values or when we graph that we figure out what these 2 points are, because we need those points. If we use a table of values and we picked 2 and 4 for our table, we would find the 0. But if you didn't pick them, you would need to pick some more to find it. Or you can graph this using a graphing calculator or Sketchpad or other technology, and then you'd be able to zoom in really close and find that on your graphing calculator. Or in Sketchpad, here it is in Sketchpad, the same. Oh, I think I mixed up my my order of my slides a little bit. I didn't show this one on Sketchpad, but that's okay. I wanted to show you how we could zoom in on this. So we have x squared minus 6x plus 8. X squared minus 6x plus 8. I'm going to add another page here and graph that. So here's how you would graph that. It was y, or f of x, equals x squared minus 6x plus 8. And here's our graph. Now right now, I can't tell exactly where it's crossing the x-axis, although it sure looks like 2 and 4. But we could do several things. We can zoom in, take this point here, and make it, drag it away from the origin to be able to zoom in. And now I can see even better that it's going through the point 2, 0, and 4, 0. You can also, if you can't see everything you need, you can change this to a rectangular grid. And then you can also, you get an extra point here that you can move around as needed. You can also put a point at the intersection. Now if I want to put a point on my parabola, on my quadratic, see how it turned red when I did that? If I wanted to put it on the x-axis, that will turn red when I get right there. If I want to put it where they're intersecting, make sure both of them turn red. See how they both turned red? And then I can go to measure coordinates. And that's the coordinate right there, which is what I thought it was. You can also do this. Select your graph that you just did. Select the x-axis and go to construct intersections. And now both points have been created, constructed, and if I go to measure coordinates, I will get the coordinates of both of them, which was the answer to this question. So there's some really great tools in Sketchpad to be able to find where the zeros are from a quadratic function. All right, so going back to we did this, we found the zeros, and this is on a graphing calculator. You can find the zeros this way as well. Okay, here's another example. This is the example, this one's from your worksheet, of negative x squared minus 2x plus 3 by using a graph and a table. So we can see that it's going to open downward. We know that it's going to cross the y-axis at 3. We can find out other things, like we can find the vertex and the axis of symmetry. Or you can graph it in your technology or Sketchpad. And from there, you can also find the vertex and things. If you use this little equation, x equals b over negative b over 2a, we know that a in this problem is -1, b is -2, and if we need it, c is 3. So we would have -2, which is 2, over 2 times -1. So we got our x coordinate of the vertex is -1. To find the y coordinate, remember you just plug that in to your equation for x so that you can then solve and find the y coordinate. And we end up with a y coordinate of 4. So our vertex right here is at -1, 4. That's just to help us graph this. Here's this enlarged a little bit. From this, it's easier to see that your zeros are here and here. And again, I showed you how to use the tools in Sketchpad to find the intercepts of the x-axis and the graph and find that the zeros are exactly at -3, x equals -3, and x equals 1, which is the same thing I found in, I'm going to go back to your sketchpad graph. You can see it from that graph as well. This is a different problem. All right, find the zeros of f of x equals -x squared minus 2x plus 3 by using a graph and a table. So if you were not graphing by hand, you could put that into your graphing calculator as a table, and you can see that the zeros of -3 and 1 were what we indeed found. We can also find our zeros by using algebra. We know that when this is true, then we will have found our zeros when we know what x is going to be equal to. From the examples that we've just done, you've seen that often there's going to be two places where x will be true. The roots of an equation are the values of the variable that make the equation true. So when we're looking for the solutions, we will be asking you to find the roots of the equation. All right, so in order to do this, we have to factor. When you have an x squared expression, we factor to find what x is going to be equal to. So here's a review of foiling. Foiling is when you have two binomials and you're multiplying them together. So you would take f times, f stands for first times first. So you take x times x. O stands for outer, which means you take the outermost letter times the outermost number. So x times 6. I stands for inner, so you would take the two closest together and multiply them, 3 times x. And then last would be 3 times 6. So we'd have x times x, that was our first times first, that's x squared. The outer was x times 6, which we'd write as 6x. The inner was 3 times x, which we write as 3x. And the last times last was 3 times 6 is 18. Then you combine your like terms, 6x plus 3x is 9x. And here's our quadratic, x squared plus 9x plus 18. Let me just do one more example here. This is a review of how you could get a quadratic function. So let's do x minus 2 and x minus 4. So first times first would be x times x. So we'd have x squared. The outer would be x times -4 because the sign in front goes with it. So that'd be minus 4x. The inner would be -2 times x, which is -2x. And the last would be -2 times -4 would be a positive 8. Combine your like terms, and we would get this. Now, what if we want to undo this and find out what was multiplied together in the first place? That's factoring. Factoring is the opposite of foiling. It's when you undo FOIL. So here's what we do. Let's say that we had this as our quadratic, which is the first example we did on the last page. If we want to factor x squared plus 9x plus 18, we know that we have to end up with two binomials. And we know that the first term times the first term was x squared, so it must be x and x. So we set it up so that we have parentheses, parentheses, x and x. Now we have to figure out, we could do outer and inner, but that's harder. So we're going to jump to the last times the last. The last times the last has to be equal to 18. Well, what's equal to 18? We could do 2 times 9 to get 18. We could get 3 times 6 to get 18, or we could do 1 times 18. In order to find the right one, pick the one that also will equal the middle term, which would be the outer plus the inner. All right, let's see if it works. So I want to pick x plus 3 and x plus 6. So now we check. So x times x is x squared. 6 times x is 6x. 3 times x is 3x. That's the outer plus the inner. And then the last would be last times last. That would be 18. And when we add our outer plus our inner together, we do get what we started with, which was x squared plus 9x plus 18. So we factored and found x plus 3 times x plus 6. Now, why do we have to do this? We have to do this because we will be factoring our quadratics to find the roots, to find the zeros. Here's another example of factoring. This is on your worksheets. And now let's practice factoring. All right, so first of all, we didn't talk about this, but sometimes there's a common term, a common factor in both of them. Like in both of these have a 3 that we could factor out because they're both divisible by 3. They also both have an x that we could factor out. So you take the common factor of 3x and you put it in front, and then you say what would be left if I took 3x squared divided by 3x. The 3's would cancel, and I'd be left with just x. Then you do the same thing to this. You say, what if I divided negative 12x by 3x? The x's would cancel, and I'd be left with just minus 4. So this is this one factored. It's not the opposite of FOIL because it's not going to be two binomials multiplied together. But number 2 is, this is very similar to the one that we did, except for the negative. Let's see. We know that this is going to be x, x and x. But what about the last term, 18? The factors of 18, we talked about these, are 2 and 9, 18 and 1, 6 and 3. Or what if we had both of those factors be negative? That would also equal a positive 18 when we multiply them together. And negative times negative is positive. We want to choose the pair of factors that equals a negative 9x for the middle term. So we need a negative 9. We need the sum of these to be negative 9. That's positive 9. If we add these together, we get negative 11, negative 19. There's our negative 9. These are the factors we want. So in my parentheses, I write minus 6, minus 3. And we check with FOIL. So x times x is x squared, minus 3x, minus 6x, plus 18. And then we can see that our middle terms will add together, and we will get the original, these two things should match. Number 3 is a special factoring that you learned about in Algebra 1, and that's when you have no middle term. In other words, the middle term is 0, 0x. So we can really still set it up the same way. We know we need an x and an x. We need the factors of negative 49 that when we add them equals 0. Well, 7 times 7 equals 49. If one of these was a negative and one was a positive, when I multiply them, I'd get negative 49. That's good. And when I add them, I would get 0. So your factors are going to be x minus 7, x plus 7. Now in all of these, your parentheses can be, you don't have to, I could have wrote this as x plus 7, x minus 7. They don't have to be in the same order. Multiplication is commutative, so this could be x minus 3, x minus 6. That's not going to matter at all. All right, so that's a review of factoring because you're going to apply that now to your quadratic functions. So functions have zeros or x-intercepts. Equations have solutions or roots. So function is when we have f of x equals, that's a function. An equation is when it's y equals something. So to be very accurate, we would only refer to zeros or x-intercepts if it was a function. If it was an equation, we would talk about the roots. If we have a graph, we would talk about zeros or x-intercepts. If we have just the equation given and without even talking about it being a parabola, then we would just talk about the solutions or roots. The zero product property says that if you have two things equal to 0, then one of them has to be 0. Like if you have x minus 2 times x plus 4 equal to 0, that means either x minus 2 equals 0 or x plus 4 equals 0. One of those has to be true. All right, we're going to find the zeros of this function by factoring. So how do we do that? First, we are going to figure out when x squared minus 4x minus 12 is equal to 0. Then we are going to factor. So they already wrote the factors in here, but how would we find them? What we do is we look at the last term, the negative 12, and we list the factors of negative 12, remembering that we're trying to find the factors that would add together to equal negative 4. So we might try negative 12 and 1, but the sum of that does not equal negative 4. We might try negative 4 times 3, but that's not going to work. And they found that negative 6 times 2 would work because when we add negative 6 plus 2, we would get negative 4. So then they factored and got x plus 2 times x minus 6 equal to 0. Now we use the property that we just learned, the zero product property, to write two little equations. We take the x plus 2 and put it equal to 0, or the x minus 6 equals 0. So you write both of those. Then you solve these little tiny equations by subtracting 2 from both sides and getting x equals 2, negative 2, or add 6 to both sides and get x equals 6. So these are the zeros of our function. We can check those by plugging them back in and making sure that we get 0 for both of them. So that you take your negative 2 and replace it into the equation, and that works, and put your 6 back in and make sure you get 0. You can also check them by graphing. Here's an example where there's a common factor that we need to factor before we can look for, the trinomial factoring. So set it equal to 0 and then factor out any common factors, which is 3x, so 3x times x plus 6. Now, we're still going to use the zero product property. That means that this is equal to 0 or this is equal to 0. So we write two separate equations and solve them both for 0. Well, if you divide 0 by 3, you get 0. So this is x equals 0, and this would be x equals negative 6. So we still get two zeros. One would be 0, and one would be negative 6. We can check those by plugging it back in. The 0 one is really easy. If you put 0 in for x, you would get 3 times 0 plus 0, so that's equal to 0. For the negative 6, let's see, you'd have negative 6 squared, that's 36 times 3, plus 18 times negative 6. And we would find that those are 108 minus 108. And also we can graph this, and we can see that this parabola, this quadratic function, crosses the x-axis at negative 6 and at 0. Here's a couple more from your worksheet. And I wanted to look at these, first of all, because this is a negative, which can make us have a hard time. So we saw what we do. We should take negative x squared minus 6x minus 9 equal to 0. Now, with the negative, we could do this. We could say, I'm going to factor a negative out of every term because it's common to every one, which creates an easier equation to work with. And then I could divide both sides by negative 1, and I would just get x squared plus 6x plus 9 equals 0. And I'm going to factor it. And let's see, the factors of 9 that equal 6 when you add them must be 3 and 3. And this is equal to 0. And then we would set each equation equal to 0 using the zero product property. And of course, we're going to get the same thing. So what does that mean graphically? It means both of these, there's only one 0. If it's the same thing, there's only one 0. Let's graph this one. Negative x squared minus 6x minus 9, and see if we get x equals negative 3 as our 0. Okay, go back to my sketch pad. I'm going to add a new page. So I go to File, Document Options, Add Page. Okay, so the function was the original, before I divided everything by negative 1, was negative x squared minus 6x minus 9. So it's going to open downward. And look at it, only touches the x-axis at one point. That's where the vertex is. I can select both the x-axis and the function I just graphed and go to Construct Oh, I've got some other stuff selected. Select both of these and go to construct intersection. Oh, it's not going to let me because it's just touching it at that point. But I'll just put a point there. I forgot that Sketchpad is very picky about what they consider an intersection versus what algebraically we consider an intersection. But there's the point, and we can measure that point. It might not be super accurate. It might say, yeah, see, it's negative 2.99. It's not letting me select the x-axis at the same time because the graph doesn't pass through it. It just touches it at that point. So Sketchpad is not as precise about that as Algebra is. All right, going back to the the lesson here. Here's another example. This one is tricky because there is no common factor that I can factor out of each, and because this is not 1. There's a 2 in front of the x squared. So we know that we're going to set this equal to 0 like this. And now we want to figure out what are the factors so that when we FOIL back, we would get 2x squared plus 9x plus 4. So I put a 2x here because I know I have to go 2x times x to get 2x squared. Now, what are the factors of 4? They're either 1 and 4 or 2 and 2. They also could be negative, but that's not going to make sense for the 9. Now it's kind of a guess and check sort of thing. Oops. Let's try the 1 and 4 first. Put a 1 here and a 4 here. And I'm going to check with FOIL. I must check with FOIL because I might have picked the wrong pair. So, first times first would be 2x squared. Yeah, that's good. Then I would have 2x times 4 is 8x. Ooh, this looks good. Plus 1x is 9x. That's going to be good. Plus 4. So I think I picked the right ones because this would be 9x. But what if I had put the 2 in? Then when I FOILed it back, I would see that I had the wrong factors because I would get first times first would be 2x squared. This would be 4x. And the inner would be 2x. So it's the middle two terms added together that is going to make or break your factoring. So when you have a number in front, you might have to try a couple different factors. These were the ones that work. That means that the two equations will be 2x plus 1 equals 0, or, using the zero product property, x plus 4 equals 0. So the first equation, when you solve this, you have 2 steps. It's not just a 1 step. You have to divide by 2 to finish this off. The other one you can finish, and you'll get what that one is for when x is equal to 0, or when x plus 4 equals 0. So you'll still get 2 answers. All right, there is an application problem that says any object that is thrown or launched into the air, such as a baseball, basketball, or soccer ball, is a projectile. The general function of that approximates the height h in feet of a projectile on Earth after t seconds is this. So this is taking gravity into account, and the velocity that you kick the ball at or throw the ball at, and your initial height. So if you're starting at ground level, or if you're up in the air, standing on something, or if you're 5 feet up because that's where your arm is when you throw it. So this does not account for air resistance, wind, and things like that, but it does account for gravity and initial velocity and height. So here's an application of a golf ball hit from ground level. So the height, the plus at the end is going to be 0. It's hit from the ground. It has an initial velocity of 80 feet per second. And the question is, after how many seconds will the ball hit the ground? So the negative 16 t squared stays in every one of them. We plug in our initial velocity of 80 here. This is going to be 0 because it's hit from ground level. So we can write an equation of a projectile using this general, what did they call it? A general projectile function. And then, of course, you can graph it and you can find the zeros and so on. So here's negative 16 t squared plus 80 t. On this one, we would just look for our common factors to factor out. So either negative 16t equals 0, which means this makes sense because at 0 seconds you haven't hit the golf ball yet, so that is a 0. And the other one will be at t minus 5 equals 0, which would be when you're after 5 seconds the ball will also hit the ground. And you can check with graphing. I think I have this one in the Sketchpad file that I've been using. Let me double check here. Yeah, it's right here. I wanted to show you this because, is this the same one? Yep. I wanted to show you this one because when I first graphed it, it's very hard to see the whole picture of what's going on. So I'm going to go to Graph Grid Form and change it to a rectangular grid so that I can see more of the height. Whoa, there we go. And then we can see, of course, that the golf ball at 0 seconds, the x-axis is our time in seconds, and our y-axis is the height at different times. You might also be asked to find when this would be the highest point, at what time. So if you looked at the graph, it looks like about 2.5 seconds. You can put a point there, and you can measure the coordinates of that point and see it's at 2.51, they say, but that's 2.5. So at 2.5 seconds, it's at 100 feet. But we're looking for the zeros, which would be here and, of course, here. And that would be at 5 seconds. And that's about it for this video. We will continue solving some more problems in the next video. Thank you very much. Have a great day. Talk to you soon.